differentiating inverse trig functions. There's a formula to differentiate inverse sine, which is 1 over the square root of 1 subtract x squared. The formula for the derivative of inverse cos is negative 1 over the square root 1 subtract x squared. And the formula for the derivative of inverse tan is equal to 1 over 1 plus x squared. These are not given in your formula sheet. So I would recommend you learn these and use them. In your notes there is a derivation of how these come about, but that's not necessary for you to know that in order to actually complete the questions. Example 1. We differentiate inverse cos of the function x cubed. So we're going to do this using the chain rule and the formula for the inverse cos derivative. First we'll replace x cubed with a substitution u. U is equal to x cubed. Now we find the derivative with respect to u of cos, inverse cos of u, and the derivative of u with respect to x. Derivative of u with respect to x is 3x squared, and the derivative of the inverse cos equals negative 1 over the square root of 1 subtract u squared. Putting these parts together, the chain rule tells us that to do d dx of your function inside a function, you do d du of cos u multiplied by du dx, which we've just worked out. So the derivative of your inverse function was negative 1 over the square root 1 subtract u squared. And we've already worked out du dx on the other page, which was 3x squared, or the derivative of the inner function here. This derivative. Finally, we can complete this by multiplying negative 1 by 3x squared on the numerator and substituting back in for u. 1 subtract x cubed squared. Sub u. So the final answer is negative 3x squared all upon the square root of 1 subtract x to the 6 using rules of indices. Example 2. As log 1 plus inverse sine x. We're going to find the derivative, d dx. So again, this is just a chain rule. The big function is log, that's on the outside, so we differentiate log. I'm just going to write 1 over 1 plus inverse sine x. So that's the derivative of log. Now we multiply by derivative of our bracket, this one. Derivative of 1 is 0. derivative of inverse sine using the formula is 1 over the square root 1 subtract x squared. So that's our answer. Just need to tidy up. Multiply the numerators, 1 times 1, multiply denominators, write it in a sensible order. Square root 1 subtract x squared can go first, 1 plus inverse sine x. So it doesn't really matter which order they go in the denominator. Example 3. Find the derivative of x squared inverse tan. So this is the product rule. First we take the derivative of the first function, which is x squared, 2x, multiplied by the inverse tan, left alone. Then add x squared, left alone, and multiply by the derivative of inverse tan using the formula 1 over 1 plus x squared. Tidy up the terms. 2x inverse tan x plus x squared over 1 plus x squared. That's our answer. Example 4. We need to find the gradient of the tangent to the curve y equals inverse cos of 2x subtract 1 over 3x subtract 2. So it's the gradient when x equals a half. So if we're finding the gradient, that really means gradient equals dy dx when x equals a half. So we find dy dx and run the point x equals a half through to find a value. So our original function is the inverse cos of a function. So it's a chain rule, function of a function. You can represent the original as y equals inverse cos u, with the substitution u equals 2x subtract 1 over 3x subtract 2. Why is the inverse cos of u? So dy du, just remember the formula, negative 1 over the square root 1 minus u squared. U was a quotient, 2x subtract 1 over 3x subtract 2. Du dx, we use the quotient rule. Differentiate the numerator, that's just 2, multiply by the denominator bracket left alone, then subtract the numerator multiplied by the derivative of the denominator, which is 3. So I'm going to squeeze the 3 in here, because those two are multiplied. Divided by 3x subtract 2 all squared. Tidying up the numerator, 6x subtract 4, subtract 6x, add 3, all upon 3x subtract 2 all squared. 6x and 6x cancel, and we're left with negative 4 plus 3 on the numerator, negative 1 over 3x subtract 2 all squared. Completing the chain rule, the derivative is dy du multiplied by the u dx. dy du is -1 over the square root 1 subtract u squared multiplied by -1 over 3x subtract 2 all squared. Now we have to sub in for u. We had dy dx equals 1 over square root 1 subtract u squared 3x subtract 2 squared. So what I've done from the previous slide is just multiplied the numerators together. -1 times -1 is this one here, and the denominator is just copied from the previous slide. Replace the u, this one, u squared, with 2x subtract 1 over 3x subtract 2. Square root 1 minus 2x subtract 1, 3x subtract 2, all squared. So it looks a bit messy, but this is the answer for the derivative. That's the derivative done. We need to evaluate this when x equals a half, but there are lots of terms that simplify. So we're just putting a half in where we see the x. So it's 1 over the square root 1 subtract this bracket, it's just 2 times a half subtract 1. That numerator there inside the bracket is 0. Then 3 times a half subtract 2 all squared. So this whole bracket that I've completed is actually equal to 0, so it simplifies. This is 3 times a half subtract 2 all squared. So this bracket works out as 0. And the other bracket, 3 times a half is 3 halves, or 1 1/2, subtract 2 would be -1/2. -1/2 squared is a quarter. So all of this ends up being a quarter. So we've got 1 subtract 0, 1 subtract 0 in the square root, which is just 1, and this is a quarter. So finally we have 1 over 1 times a quarter, which is just the same as 1 divided by a quarter, or 4. So the gradient of the tangent at x equals a half is 4. M equals 4 gradient.